Are you ready to take on Ethernaut's Fallout Challenge? In this exercise, you'll learn how to exploit vulnerable smart contract and steal all its ether. Follow my step-by-step guide and let's start hacking. Okay, let's begin with the Fallout Challenge. So over here, you can cd to your directory and run Brownie init. However, since I have already ran this command, this will be produced. Now I'm going to explain the code of the contract. First of all, the Solidity version, and then remember in the previous challenge we have to import this OpenZeppelin safe math file from 4.8.0. Now I have import from 3.0.0 due to the Solidity version. Now over here you can see that this OpenZeppelin is actually from this directory. Brownie packages OpenZeppelin.safemath, and the reason that it is actually shortened is because in my configuration file I have actually remapped it into @OpenZeppelin, and this file actually contains all your Brownie configuration. So over here it just tells Brownie to get your environment variable from your environment file, and this is your wallet, your private key from the environment file. So this Web3 Infura ID is basically to connect to the Infura node provider, which provides Web3 services for you to interact with the blockchain. Now let me further explain the contract. This is a contract name, then they are using the SafeMath library from OpenZeppelin, and the hash map or dictionary for allocations, basically the wallet address to the amount allocated, and this is the address of the owner. Now, this is the constructor, which I will further explain later. I'll first explain the other functions first. Over here, we have the modifier, which is basically applied to other functions. For example, over here, you can see that collect allocations. So what this collect allocation function does, it allows the contract owner to collect all the ether stored in the contract. It uses the transfer function to send all the ether stored in the contract to the contract owner. The function is marked with only owner modifier, so which means that it can only be called by the contract owner. Now let's go back to allocate. So this function allows external actors to add to their own allocation by sending ether to the contract. It updates the allocation mapping, which is over here, to add the value of the ether and received in the function called to the sender's allocations. Now over here we have a send allocation function. So this function allows an external actor to send their allocation to a specified address. It checks that the sender has a positive allocation and then sends the allocation to the specified address using the transfer function, which sends ether from the contract to another address. And lastly, we have the allocator balance function. So this function allows external actors to check the amount of their allocation. It takes an address as an argument and returns the corresponding allocation from the allocations mapping, which is over here. So the function is marked as view, which means that it only reads data from the blockchain and does not modify it. Now I'll further explain the contracts, what this constructor means. So basically what this constructor does is basically the owner variable is set to the address of the contract's deployer, which is message.sender, and the allocations mapping, which is the data structure that maps addresses to the uint, which is unsigned integers. So this is updated to add the value of the ether received in the function called to the deployer's allocation. Okay, so let me give you another example in this contract. So in this example, the constructor function is defined with the same name as the contract mycontract, and it takes a single uint argument called -x. So when the contract is deployed, the constructor function will be called and initialized, and the value of -x will be passed in as an argument. The constructor function then assigns -x to this x variable, which is marked public and can be accessed by external factors. This was actually introduced in Solidity version 0.4.22, which was introduced in 2017. So before 2017, this was how their contract constructor was created, by using the same contract name as the constructor. Now, let me explain how do we interact with this contract. Firstly, we can create our interface so that we can interact with our contract Fallout. Firstly, we want to get our essential function, which is Fallout, our constructor, which has not been initialized, and then we can get the owner variable. And then lastly, we can get this important function, which is to steal all the funds in this particular Fallout contract. So to solve this, we have this Brownie Python script. We get the contract address, and then we can get the player's address, which is in our env file. So this address can be taken from Ethernaut console, and this is our instance. So to interact with our interface, we have to pass this address over here so that Solidity and Brownie knows that we are interacting with interface iFallout. So to solve this challenge, we can call the Fallout function, and you can see that we have to pay one way because this function is payable. And then over here, we can get all the funds deposited in this contract and specifying who to transfer the funds to. So to solve this, let's just run the script. You can see that the block is trying to be mined. So firstly, this transaction is sent and then waiting for the block to be mined. So this function is being called first. After this function is called, we become the owner of this whole contract. So we have become the contract's owner, and now we want to steal all the funds in the contract. This is an additional step which I recommend whenever you finish an Ethernaut challenge. Try to steal all the funds in the contract. And see, the final balance of the contract is 0, and thus we have successfully solved the Ethernaut Fallout challenge. If you think that you have learned something from this tutorial, please hit the subscribe button and drop a like. Thank you for watching and have a nice day.